Most people managing blood sugar are focused on one thing: what they eat. The glycemic index of their bread, the sugar content of their fruit, the carbohydrates in their dinner, the timing of their meals, and all of that matters. We have spent this entire series talking about it. But there is something happening in the background that most people are completely unaware of. Something that is quietly making every blood sugar intervention less effective. Something that gets worse every year, automatically, without any warning signs, until the damage is already significant. It is happening in your muscles. And once you understand it, you will realize that managing blood sugar is not just about what you eat. It is about protecting the tissue that processes blood sugar. And that tissue is muscle. Today, I want to talk about something called the protein threshold. What it is, why most people over 60 are not meeting it, and why failing to meet it is slowly dismantling the most important blood sugar management organ in your body, which is not your pancreas and not your liver. It is your skeletal muscle. Let me start with a fact that surprises almost everyone. Your skeletal muscles, the muscles of your arms, legs, back, and core, are the largest site of glucose disposal in the human body. Roughly 70 to 80% of the glucose that enters your bloodstream after a meal is taken up by skeletal muscle. Not the liver, not fat cells, not the brain, muscle. When you eat a meal containing carbohydrates, your blood sugar rises. Insulin is released. And insulin signals your muscle cells to open up and absorb that glucose, either to use it as fuel immediately or to store it as glycogen, the body's short-term energy reserve for later use. This is the primary mechanism by which blood sugar is cleared after a meal, and it depends entirely on having enough muscle to absorb the glucose load. Here's where the problem begins. From roughly the age of 30 onward, the human body begins losing muscle mass at a rate of about 1 to 2% per year. By 60, many people have lost 20 to 30% of the muscle mass they had in their prime. By 70, that figure can be higher. By 80, some people have lost close to half. This process has a medical name, sarcopenia. It means age-related muscle loss, and it is one of the most underappreciated drivers of insulin resistance and type 2 diabetes in older adults. Think about what muscle loss means for blood sugar management. If your muscles are absorbing 70 to 80% of post-meal glucose and you lose 30% of your muscle mass over the decades, you have lost a massive portion of your glucose disposal capacity. The same amount of glucose from the same meal now has significantly less tissue available to absorb it. Blood sugar rises higher, stays elevated longer, requires more insulin to manage. The pancreas works harder. Insulin resistance deepens over time. Sarcopenia and insulin resistance feed each other in a cycle that compounds year after year. Less muscle means higher blood sugar. Higher blood sugar and higher insulin promote further muscle loss. Further muscle loss means even higher blood sugar. This is why blood sugar becomes harder to manage with age for so many people, even when diet and medication remain constant. The fundamental infrastructure for managing glucose is being lost, and most people and many physicians have never been told that protecting muscle mass is a metabolic health intervention. Now let's talk about the protein threshold. Muscle tissue is not static. It is constantly being broken down and rebuilt. Every day, your body breaks down old damaged muscle proteins and builds new ones in a process called muscle protein turnover. Whether you gain muscle, maintain it, or lose it depends on whether the rebuilding outpaces the breakdown. To rebuild muscle, your body needs two things: a mechanical stimulus, meaning the muscle needs to be used, and amino acids. Amino acids are the building blocks of protein. Without an adequate supply of amino acids, the rebuilding cannot keep up with the breakdown. Muscle is net lost. The protein threshold is the minimum amount of protein eaten at a single meal required to maximally stimulate muscle protein synthesis, the rebuilding process. Research over the last 2 decades, led by scientists including Dr. Stuart Phillips at McMaster University and Dr. Douglas Padden-Jones at the University of Texas, has consistently shown that this threshold exists, that it is higher than most people consume, and that it becomes more difficult to reach with age. Here is what the research shows. In young adults, muscle protein synthesis is maximally stimulated by roughly 20 to 25 grams of high-quality protein per meal. Beyond that amount, additional protein in the same meal does not produce significantly more muscle rebuilding. But in older adults, people over 65, the threshold is higher. The muscle tissue becomes less sensitive to the anabolic signal from protein. This is called anabolic resistance. It takes more protein per meal to produce the same muscle-building response. Research suggests that older adults need 30 to 40 grams of high-quality protein per meal to maximally stimulate muscle protein synthesis. 30 to 40 grams per meal. Now consider what most older adults actually eat for breakfast. A bowl of instant oatmeal, some toast with jam, a glass of juice, maybe a banana. Total protein perhaps 5 to 8 grams. Well below the threshold, not even close to the amount needed to trigger meaningful muscle rebuilding. And if muscle protein synthesis is not adequately stimulated at breakfast, that meal passes as a net muscle loss event. The breakdown exceeded the rebuilding. A small amount of muscle is lost. This happens at breakfast. Then at lunch, if protein is again insufficient. Then at dinner, 3 meals a day, 7 days a week, 52 weeks a year. Small losses accumulating into significant muscle loss over months and years. And every gram of muscle lost is a reduction in glucose disposal capacity. More blood sugar circulating, more insulin required, more metabolic strain. Let me tell you about a patient named Vincent. Vincent was 71 years old, former civil engineer, active man. He walked every day, took his blood pressure medication, ate what he considered a reasonable diet. He had been diagnosed with prediabetes 2 years earlier and was managing with lifestyle changes only, which he was proud of. But his A1C had been creeping upward, slowly. 0.5 point over 18 months. When I reviewed his diet in detail, his protein intake was striking in its inadequacy. Breakfast, oatmeal with fruit, protein about 6 grams. Lunch, a salad with some vegetables and a small piece of cheese. Protein, about 12 grams. Dinner, the best meal of his day, usually fish or chicken with vegetables. Protein, about 30 to 35 grams. Total daily protein, roughly 50 to 55 grams. For a man of his body weight, the recommended protein intake for muscle preservation in older adults is approximately 1.2 to 1.6 grams per kilogram of body weight per day. Vincent weighed 82 kilograms. His target range was roughly 100 to 130 grams of protein per day. He was eating less than half of what his body needed to maintain its muscle mass. And because his protein was so heavily concentrated at dinner, the one meal he had right breakfast and lunch were essentially muscle loss events. He was systematically dismantling the infrastructure that his body used to manage glucose, one insufficient meal at a time. We did not put Vincent on a radical diet. We made 3 targeted changes. We added 2 eggs to his breakfast alongside the oatmeal. That brought breakfast protein from 6 grams to approximately 20 grams. Still not perfect, but meaningfully better. We added a palm-sized portion of canned sardines, tuna, or a hard-boiled egg to his lunch salad. Lunch protein moved from 12 grams to approximately 28 to 30 grams. We kept dinner largely the same, but made sure the protein portion was genuinely adequate, not a small slice of fish, but a proper portion. Total daily protein, now approximately 85 to 95 grams. Much closer to his target. Still not perfect, but consistently, meaningfully better. 4 months later, his A1C had stabilized. The slow upward creep had stopped. His fasting glucose had improved. And perhaps most tellingly, Vincent reported that his energy through the day was noticeably different. He no longer felt the mid-morning and mid-afternoon energy drops he had assumed were simply part of aging. He said, "I thought I was eating enough protein because I had a good dinner. I had no idea the other 2 meals were working against me." That is the protein distribution problem. And it is extraordinarily common. Now let me make this practical. There are 3 things I want you to understand and apply. The first is the daily protein target for older adults. If you are over 60, the research supports a protein intake of 1.2 to 1.6 grams of protein per kilogram of body weight per day as a minimum for muscle preservation. For someone weighing 70 kilograms, about 154 pounds, that is 84 to 112 grams of protein per day. For someone weighing 80 kilograms, about 176 pounds, that is 96 to 128 grams. Most older adults in Western countries consume roughly 60 to 70 grams per day on average, below the threshold for muscle maintenance, particularly given anabolic resistance. The second is the distribution principle. Daily protein total matters, but how that protein is distributed across meals matters almost as much. Research by Dr. Padden-Jones showed that distributing protein evenly across 3 meals, roughly 30 to 35 grams per meal, produces significantly greater muscle protein synthesis over the course of a day than the same total amount skewed heavily toward 1 meal. This means that eating 90 grams of protein with 10 at breakfast, 15 at lunch, and 65 at dinner is metabolically inferior to eating 90 grams distributed as 30 at each meal, same total, dramatically different effect on muscle maintenance. Every meal needs to meet the threshold, not just dinner. The third is protein quality. Not all protein sources are equal for muscle rebuilding. The quality of a protein is determined primarily by its leucine content. Leucine is an amino acid that acts as the primary trigger for muscle protein synthesis. It is the key that starts the engine. Animal proteins, eggs, fish, poultry, dairy, red meat are generally high in leucine and are considered complete proteins because they contain all essential amino acids in adequate proportions. Plant proteins, beans, lentils, tofu, nuts are valuable but often lower in leucine and sometimes missing one or more essential amino acids. This does not mean they are inferior for overall health, but for the specific purpose of triggering muscle protein synthesis, they are less efficient per gram. You need more of them to get the same anabolic signal. If your diet is primarily plant-based, you can absolutely meet your protein needs, but you need to be more intentional about combining sources and ensuring adequate total intake. Soy protein in particular is one of the most complete plant proteins and is relatively high in leucine compared to other plant sources. The best protein sources for meeting the threshold at each meal include eggs, which contain about 6 grams of protein each and are highly bioavailable, Greek yogurt, plain, which contains about 17 grams per cup, canned fish including sardines, salmon, and tuna, which contain 20 to 25 grams per serving, poultry and fish, which contain roughly 25 to 30 grams per 100 gram serving, cottage cheese, which contains about 14 grams per half cup, and legumes combined with a grain or dairy to improve amino acid profile, which can contribute meaningfully to the daily total. Now I want to address something you may be wondering. If protein is so important for muscle preservation and blood sugar management, why are we not talking about very high protein diets? Why not eat as much protein as possible? The answer is that beyond the threshold for muscle protein synthesis, additional protein does not provide additional muscle building benefit. The engine is already running at full capacity. More fuel does not make it run faster. What happens to excess protein? It is either used for energy or, in some circumstances, converted to glucose through a process called gluconeogenesis. Large amounts of protein at once can contribute to blood sugar rises, though this effect is modest compared to carbohydrates. The goal is not maximum protein. The goal is consistent, adequate protein at every meal, distributed through the day, meeting the threshold at each sitting, enough to keep the engine running. Not so much that you are simply adding fuel with nowhere to go. Let me also address movement, because protein alone is only half of the equation. The signal for muscle rebuilding has two components, the amino acid supply and the mechanical stimulus, in plain terms, protein and use. Muscle that is not being used does not receive a strong signal to rebuild, regardless of protein intake. The body is efficient. It does not maintain infrastructure. It does not need. This does not mean you need to lift heavy weights at a gym. Though resistance training is the most effective stimulus for muscle protein synthesis and is beneficial at any age. But it does mean that regular physical activity, particularly activity that involves some form of resistance or load, is essential for maintaining muscle mass alongside adequate protein intake. Walking is beneficial for cardiovascular health and blood sugar management, as we have discussed throughout this series. But walking does not provide a strong enough mechanical stimulus for muscle preservation on its own. Activities that do provide a meaningful stimulus include bodyweight exercises like squats, wall push-ups, standing from a chair repeatedly, and stair climbing, light resistance training using bands or small weights, swimming, which provides resistance through water, even carrying groceries, gardening, and other daily activities that involve lifting and moving against some resistance. Any consistent activity that challenges the muscles, that makes them work against a load, provides the mechanical signal that, combined with adequate protein, maintains muscle mass over time. I recommend discussing specific exercise options with your doctor, particularly if you have joint issues, balance concerns, or cardiovascular conditions. But the general principle is universal. Use your muscles, feed them adequately, and they will maintain their capacity to serve you, including their capacity to manage your blood sugar. Let me bring everything together. Your muscles are not just locomotion. They are your primary blood sugar management organ. 70 to 80% of post-meal glucose is cleared by skeletal muscle. The more muscle you have, the more efficiently glucose is absorbed. The less muscle you have, the higher blood sugar rises and the longer it stays elevated. Sarcopenia, age-related muscle loss, silently reduces this glucose disposal capacity over decades, making blood sugar management progressively harder regardless of diet and medication. The protein threshold, 30 to 40 grams of high-quality protein per meal for adults over 60, distributed across all 3 meals, is the nutritional requirement for maintaining muscle protein synthesis at a level that counteracts this loss. Most older adults are not meeting this threshold, particularly not at breakfast and lunch. The result is daily net muscle loss compounding over months and years. Meeting the protein threshold at every meal, combined with consistent physical activity that challenges the muscles, is one of the most powerful and most underappreciated blood sugar interventions available. It does not replace the other habits we have discussed in this series, it works alongside them. Protein at every meal, post-meal walking, anti-inflammatory fats, fermentable fiber, sleep protection, evening cortisol management. Each of these contributes to the same goal, a body whose internal systems are equipped to manage glucose efficiently, without constant strain and without progressive deterioration. Before I close, the reminder that belongs in every video. If you are managing diabetes or any metabolic condition with medication, please discuss dietary changes, including significant increases in protein intake with your doctor. Increased protein intake can affect kidney function in people with existing kidney disease, which is more common in people with long-standing diabetes. Your doctor can help you determine the appropriate protein target for your specific situation. If you know someone who is managing blood sugar and losing ground year by year despite doing everything else right, someone whose A1C is slowly creeping upward despite careful eating and medication, please share this video with them. The muscle conversation may be exactly what has been missing. Next week, we are going to talk about the relationship between poor sleep and insulin resistance, the last major piece of this series. Why one bad night of sleep raises your blood sugar measurably the next morning. Why sleep deprivation mimics the metabolic effects of eating a high-sugar diet. And what you can begin doing tonight, even if sleep has been a challenge for years. It connects directly to everything we have discussed, including today's muscle topic, because poor sleep accelerates the very sarcopenia we talked about today. Do not miss it. Subscribe and hit the bell. I am Dr. Sterling. Take care of yourself. And at your next meal, make sure the protein is there. Your muscles are waiting for it.